A 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and it is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in this process? Here a 600 picofarad capacitor is initially connected to a 200 volt battery. During this process, this capacitor stores some energy. Now it is disconnected from that power supply. Now this 600 picofarad capacitor is connected across another 600 picofarad capacitor. So during this process there will be a charge sharing between these two capacitors. As we know that during the charge sharing there will be some energy loss, and here we will calculate that energy loss. So as we know that the energy loss expression will be C1 C2 divided by 2 times C1 plus C2 into V1 minus V2 whole square. Here C1, C2 are the capacities of the capacitors, and V1 and V2 are the potentials to which they are charged initially. Shall write here V1 and V2 are the potential difference to which they are charged. So here in this given situation, I will consider this is one 600 picofarad capacitor which is connected initially to a 200 volt supply. This is your 600 picofarad capacitor. Now this capacitor is disconnected from this supply and it is connected to another capacitor of same capacity, that is 600 picofarad. So during this process of charge distribution, or we can say redistribution of charge, there will be some energy loss, and this will be the expression for that energy loss. We will just substitute the values in this equation. C1, C2 both being 600 picofarad. I'll write the result here: 600 into 10 to the power minus 12 whole square divided by 2 times C1, C2 both are again 600 picofarad. So 2 times 600 into 10 to the power minus 12. And V1 minus V2, here V1 is the potential difference across the first capacitor and the second capacitor is initially uncharged. So V2 will be 0 here. So we'll put the value V1 as 200 here. This will be 200 minus 0 whole square. And the final result will be 6 into 10 to the power minus 6 joule. That is 6 microjoule. This will be the energy loss in this process. We can also calculate the same result by conventional method. That means we can calculate the initial energy in the first capacitor, and after connecting this capacitor across another capacitor, we can calculate the final energies, and we can just subtract the initial result and the final result we will calculate, and we'll get the same value, which is 6 microjoule over here.